So let's look at changing exponential to logarithmic. Okay, if I have 2 cubed equals 8, okay, this is my base, 3 is my exponent, and 8 is what we call an argument. So when you switch them in log form, it's going to be log base 2, so the base goes down here, of your argument equals your exponent. Okay, so as long as you have this on the left, kind of think of it as left, right, or left, right, middle. So left, right, middle. 2 cubed equals 8. Left, right, middle. So when you're rearranging them, 5 to the 0 power equals 1. That's log base 5 of 1 equals 0. A logarithm is basically an exponent. You're trying to find a way to solve for your exponent. If I have e squared equals 7.4, that is log base e of 7.4 equals 2, okay? Or the common name for log base e is natural log. So you want to change log base e to natural log. Okay, so let's try a couple practice problems. So we have log base 2 of 32 equals x, and we want to simplify. So you're going to rearrange. So this is our problem. So we're going to rearrange left, right, middle. So that's 2 raised to the x equals 32. And right now, 2 to the x equals 32, you should know what that is. That is 5. If not, we're going to break 32 down. If you're not sure what it is, break it down, use a factor tree. 2 goes into 32 16 times. 16 is 4 and 4. 2 and 2, 2 and 2. So I can rewrite 32 as 2 to the 5th. And once my bases are the same, my x equals 5. Okay, that's my first example. Okay, next example, I have log base 4 of square root of 32 equals x. That is my problem. So we're going to do the same thing, rearrange. 4 to the x equals square root of 32. So right now I can't do anything with these because they are separate bases. And I have this radical here. So we're going to change this radical to an exponential function. And if this is a square root, that means that the number in the little radicand here is 2. So square root is the same thing as changing it to the 1/2. So make sure that if you have a 5th root, that means x to the 1/5. If you have an 8th root, that means x to the 1/8, etc. Because you're going to have to use those several times this year. Now my goal is to get this down to the same base if I can. This is not going to be so obvious what my answer is. So I can break down 4 into 2 squared. And I can break down 32 into 2 to the 5th. We just did that. And then you use your properties of exponents. So this is going to give me 2 to the 2x equals 2 to the 5/2. You multiply exponents when you have a power to a power. Once your bases are the same, you can set their exponents equal to each other and solve. 2x equals 5 over 2. Divide both sides by 2. And just to refresh your memory on simplifying fractions, and you're going to have to do this a lot, so I would kind of remember this. Remember, copy dot flip. We're going to copy the first fraction, which is the 5/2. I'm going to change division to multiplication, and I'm going to change that 2, which as a fraction is 2 over 1 to 1 over 2. It gives me 5/4. So my answer is 5/4. Next problem, if I have 1/5 to the x plus 1 equals 125, okay, again, I'm going to try to get the same base. 1/5 you got by putting the 5 in the denominator because you had a negative exponent. So I would get used to, if you have 1 over a, that means a to the negative 1. Get used to your fractional numbers as negative exponents. And then 125, if you're not sure, 125 we're going to break down into 5. So 125 is going to give me 5 times 125. Let's see. 125 divided by 5 is 25. And then 25 breaks down to 5 and 5. So 125 is 5 cubed. Once my bases are the same, you're going to have to multiply this out. So this is 5. Distribute my negative 1. Make sure you're careful of your exponents. And that's going to equal 5 cubed. Now I can set my negative x minus 1 equal to 3 and solve. And it's just a matter of going back and doing your algebra 1 and solving. So my x equals negative 4. Next problem, I have log base 3 of negative 2, and I want to simplify that. So if I rearrange this, this is 3 to the x equals negative 2. So you'll notice that you're not going to be able to get these the same base. But you need to think in your head, 3 to what power is going to give me a negative number? Well, this is what you should be thinking in your head. So if I do 3 to a positive number, I'm going to get like 3, I'm going to get 9, I'm going to get 27, etc. So it's going to be a positive number. If I do 3 to the 0 power, that's going to give me 1. If I do 3 to a negative number, that's going to give me 1/3, 1/9, 1/27. So no matter what you do, you're going to get a positive number when you do it. So this is not possible. You are never going to get a negative number when you raise a number to an exponent. So one of your golden rules, and you might want to remember this, is, so this is your argument will never be negative or a 0. So you'll never have either of those there. Okay, let's try some other ones, some basic simplifying things. If I have 8 raised to the log base 8 of 4, and I want to simplify that, okay, this you're kind of combining exponential, oops, I didn't mean to do that. So here you're kind of combining an exponential and a log, and remember they're inverse each other. As long as this number is the same as this one, this is my answer. So my answer is 4. Okay? So what do I do if it's not the same number? So for example, if I have 8 log base 2 of 4, okay, you'll notice these are not the same base. However, 2 and 8 do kind of have something in common. I can change the 8 to 2 cubed. Okay. And if you remember your properties from Algebra 2, which I'm kind of getting ahead of myself, but you can move that up here, and that gives me 2 log base 2 of 4 cubed. And once these two bases are the same, my answer is 4 cubed, which is 64. But we'll do more on these properties next time. I kind of jumped the gun ahead, but if these are the same, you can do it. The other option you have is log base 2 of 4. Let's do it this way. If I have 2, 3, log base 2 of 4, okay, I can work on this part first. You have to think in your head, 2 to what power is 4? And the answer to that is 2. So really, the answer to this part is 2. So really you have 2 to the 3 times 2, which is 2 to the 6th power. 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2, which will give you 64. So you end up with the same thing, you just went about it a different way. This way you use the properties we just had in this section. This one you'll use the properties that either you learned in Algebra 2 and you might remember, or we will learn again in a couple sections. Let's try another one. If I have log base 3 of 3 to the 7th, as long as this base of the log and the base of the exponent are the same, oops, that's my problem. This is my answer, 7. So if I have log base 2 of 4 to the 3x, obviously these bases are not the same, but I can get them the same. I can change this to log base 2 of 2 squared, but there's still a 3x there. So log base 2 of 2 to the 6x. And as long as this base is the same as this one, my answer is 6x. Okay, here's a couple other ones. I have natural log of e to the 1/3. Natural log means log base e. So again, as long as this base is the same as this one, 1/3 is my answer. If I have log base 7 of 1 over 49, and I want to simplify it, the easiest thing to do is set it equal to x and rearrange it. 7 to the x equals 1 over 49. And again, we kind of did these earlier. Get your bases the same. Well, this 1 over 49 came about because that 49 is in the denominator because it had a -1 exponent. Then I can change the 49 to 7 squared. And that's 7 to the -2. And once those bases are the same, my x equals -2. Okay, if I have log of 10,000, okay, one other thing that you may remember is if you have log of x, so this is something in your brain you should remember maybe from Algebra 2, that means log base 10. So it's off of a base 10 counting system. So if it doesn't have, oh, that's an ugly arrow. If it doesn't have a subscript there, then you assume it's 10. So this really means log base 10 of 10,000. So you should think in your head, 10 to what power is 10,000? And really, you just count this number of zeros. So the answer to that is 4. Okay, next one, if I have 10 log of 12, again, it's understood that this exponent, or that this subscript base is 10. So if I have 10 log base 10 of 12, as long as my two bases are the same, my answer is 12. So e to the natural log of 4, okay, again, e, natural log is log base e. As long as my bases are the same, that equals 4. And last one, if I give you ln of 7, okay, there's nothing you can do on this. This is log base e of 7. There's no way to simplify it. You can't think in your head e to what power is 7. So you're just going to have to type in natural log of 7 in the calculator, and that's going to give you 1.95. This is just plug it in the calculator. There's a natural log button on the calculator that you'll press.